Page 14. Tough crowd. That's okay. Anyways, we'll finish the domain and range on this page. I think you should have a bunch of examples. I used green and pink for just to highlight where the domain and range would be located. And if you did all of these, and today was just a piece of cake for you, way to go, right? So for domains, you look at your curve. It starts at 0, and you kind of follow it. Look at that, interactive, right? So that's your domain, the x values for which your graph exists. And for the range, you might think, hey, wait a minute, what's happening here? You kind of want to understand that 0 is the highest, and it stops right here, right, with this. So your y value span between the lowest, which is 0, and the highest, which is 18. So domain 0 greater than 17, and then we go 0 to 17 here. And so for range, we'd go from 0 all the way to 18. That's the vertex usually tells you what the cap is, right? Either on the low end or on the high end. It depends on what's happening. So there you go. Okay, so domain and range. Okay, so next one, what's up here? This is a scenario where, I don't know, think of maybe a submarine launching a missile from under the water, right? Goes up and supposed to strike something on the ground, right? So this is kind of like the path. Kind of imagine that's what's happening here, or you can think of various scenarios, I'm guessing. So anyways, for your domain and range, this one gets a little trickier, I will not lie to you. But look at this domain, it's still talking about the x value. So you start here and you keep going, you see the graph, and that's when the graph stops, right? So for your domain, in this case, it would be 0, 0, all the way to time 10. And this could be a decimal down the road, so don't get too comfortable. And right, and the set interval notation will be 0 to 10. So this projectile hits ground at 10 seconds. And then the range, it's a little trickier, right? So you go all the way from here, and the highest y value that appears, right, in this scenario it's determined by the vertex. Okay, so you go from -20, remember it's always the lowest, right, and we still use h, all the way from -20 to, in this case, the y value, the highest y value that we encounter is 3. So this is -20 to 3, and it's always inclusive when we do word problems. Okay, we're including those points. Doing okay here? One more. And I will throw this at you quite often, right? Domain and range, domain and range. You will get tired of it, but by the time you get to grade 12, Miss Yosik or me, whoever teaches you next year, yeah, I know how to do it. I know what you're talking about, domain and range. Domain and range are also known as restrictions. What are the restrictions for in terms of your x values? And what are the restrictions in terms of your y values? And the reason why we focus on that is because if you graph this on your calculator, this thing keeps going, right, indefinitely. So we need to kind of like shrink it down to, we're just considering everything from here to here, which means these x values, these y values. Okay, let's keep going one more. I know you've done domain and range in IAPR, right? I'm pretty sure you have. You had open bracket, right, like round bracket, square brackets, all of that as well. You sometimes had like an open dot. Remember those graphs? It's an open dot. That means that you don't include that end point. We don't have that here in applied. The points are always included, right? So domain here we'll soon have fun with word problems. Okay, I promise you, I'll just do this one last one here. So the domain spans from here to here. Let's do that first. 0, and we're still doing time. Lots of time along the x-axis won't always be, it could be distance. It could be distance versus height. I guess you just need to be aware of that. So we're going from time 0 all the way to, let's see, 4.5, right? So this is 0 to 4.5, like that, for your domain. So you would state either one of them. And then for your range, oh, what's the range here? What's range? So you kind of find the lowest point, right? I'm going to go dot, dot, dot. That's where I'm going to start. And you go all the way up to the highest point, which is here, right? So that is your range. So your lowest y value is 13. And what's the highest? It's right there. It's not this. It's the vertex there that gives you that information. So you're going from 13 to 32. Remember, lowest, greatest, always. Lowest, greatest. If you flip them, it'll be wrong. And now I'm going to go ahead and highlight all the R's with green. I'm going to highlight all the, hold on. I made a mistake, right? Did you catch that? Up here. Did you catch that? The domain is, my bad. It must be Friday. It's basically Friday, so my bad. Very important not to mix those up. So let me just go back to this one. If you're still writing down, we're good. Okay, I will give you more down the road. The textbook has 0 domain and range practice. 0, none. So that's where I come in, and I will give you some from time to time. Let's keep going. Something to note, this is very important because it throws students off. So this is on page 15. If you're given general form like that, if B is equal to 0, right? If B is equal to 0, you're going to notice that the graph will look like this. If B is not equal to 0, it will look more like this. Notice that the vertex is somewhere shifted off to the side. So what's the big difference? In this case, the vertex is equal to the y-intercept. Okay. So you have the vertex there. And this is also, right? This is also our y-intercept. So it's almost like the y-axis splits this parabola in half. Right? If b is not equal to 0, meaning like this, actually that x term will be there, right? The vertex is here, and the y-intercept is there. And I just inserted this slide. Basically, you're the first group that sees this, because sometimes students were confused, like, wait a minute, y-intercept and vertex are the same? I thought they were different. Sometimes they are the same. Most of the time they're not. Okay? Most of the time they're not. So example, I'll give you an example of what this formula would look like. Y is equal to negative 9.7x squared plus 5. Okay, there's no x value. Notice that? No x value. This one would be example. I will use the same one. Allow me to use the same one. Okay. Oops. Sorry. Zoom out. Zoom out. I need like a full-time cameraman or a camera woman here running this show. There. That's just the little added, the 3x, the x term shifts this thing over. And that just means most of us like this more. This throws us off, but it's still the same, it's still parabola. Okay, you're like, what's that blank space underneath? More domain and range to come. Okay, I will just add it there down the road. Not today. I think today you've seen enough. Okay. Let's keep going now. Let's actually do a word problem. And the worksheets that I'm going to assign after today do a bunch of this. A lot of questions are being asked. And last but not least, I asked you to, you'll have a nice grid to graph this. Okay. And notice that this is quadrant 1, right? I kind of focus on quadrant 1. If you ever need the second quadrant here because you're going underwater, underground, then you just add, right? You make quadrant 2 appear. But most of the time you won't have to worry about it. Remember, everything is connected, guys. Everything you're going to use second trace a bunch of times to answer these questions in various ways. Okay, so I'll show you how to do that. So let's go to page 16 here, and word problems. I say this very clearly, equation is provided. Okay, I will highlight that part because not always will the equation be provided. What do you mean, Mr. Dirksen? Just wait and see. I'll show you that. The path of a baseball that has been hit can be modeled by the following equation. And there's your equation, very important, where h of t is the height in feet and t is the time in seconds. So right off the get-go, I want you to do this, right? T stands for time, that's their x values. So that means that every single point will have time x, right? And height y, right? So not only do we talk x and y, right now we actually have a context attached to those variables, time and height, okay? Right, so what is the initial height of the trajectory of the ball? So what is the initial height? I want you to do this here real quick for me, just a sketch. This is just a sketch, not a graph. So we just imagine a baseball has been hit. Remember that you can start right on the ground or you can start off the ground. And how do we know? Let's go over here. What is that last value right there? That tells us what the y-intercept is if it's in general form, right? So that means that for our particular case, we're going to start here. And then the ball is hit and it goes like that. So just a little sketch, right? This is time. This is height. So we know that this is 0, 4, right? We will find our vertex. We will find the x-intercepts in due time. Right now, we don't care. Does it make sense that my parabola would look like this? That the vertex is somewhere over here? Yes, because B is not 0, right? There is a t there, which is like the x value, right? So you kind of expect this to happen. Very important, right? Predict, predict, predict. Okay. A. What's the initial height of the ball? At what height was the ball hit? Y-intercept is equal to 4, 0, 4, right? Initial height is for what? What's the height measured in? You got to be careful here. 4 feet. So if you tell me what's the initial height and you say 0, 4, it's not going to be quite right. You have to actually say in a short statement, just saying like it's 4 feet, right? That's what we're after. B, determine the maximum height of the ball. Max height achieved. Where would we find that information? thinking of the points that is y-intercept, x-intercept, vertex. That would be the vertex, right? At vertex. So this is where you just tell me, right? I'm going to use second trace. Is it a max or a min? Right. I probably fast. I'm going too fast sometimes because I have seen this so many times. But let's back up. There's a negative a, right? Negative a value. We expected this parabola to point down, correct? Okay, so this is a max. Let's go ahead and find it. So you're gonna have window issues, guys. So don't just follow me blindly. Type this in, okay? This one is probably gonna work out just fine, but quite often it's not gonna be the case. So you need to go through this. Type that in just like that. Make sure plot 1, 2, and 3 are off. They should not be selected. They often give you issues, okay? Later on, we will turn them on. But right now, just type it in, hit graph. I will go zoom standard, zoom 6, just so I start off same as you. And I can tell that I need to increase my Y max. I don't know, I'm gonna go 50. Still not, okay. 60, I'm gonna go 100. Go big or go home. There we go, that works. And it looks as though you're starting at the origin, but you're not, right? We know that you're not because of the y-intercept, right? It's just because when you zoom out that much, 4 seems like a very small increment, right? So let's go find our vertex. Second trace, it's on max, so 4. You got to go right somewhere to the left of it, hit enter, go over the hill. Now you are to the right of it, hit enter, and one more time. You need to have this exact coordinate. You can't just guess. And you should be getting 3.57, 66.5. So write that down. 3.57, 66.5. And you would think you're done, right? But you're not. Because I need to know that you know which of these two numbers answers the question. And the maximum height is, right? Remember, every single point, the y value is my height, this here. So just answer. Maximum height is 66.5 feet. Okay, that's all you need to do. No fancy long sentences. Just tell me the actual answer that I'm after. C. They get trickier, okay? So follow along. How long does it take for the ball to hit the ground? In other words, how long does the ball remain airborne? Okay. So how would we find that? If we found, right, if time's 0 and time passes by, we will find it at the x-intercept. We need the x-intercept as height is equal to 0 here. Okay. So let's go ahead and do that. So y2 is equal to 0. Second trace 5. And you go ahead and find that with me. There it is. And some of you might be tempted to find the first one, right? Enter, enter, enter. And watch this. It is negative. We omit that one. We do not include, right? Like our action starts at 0. So we just want that x-intercept right there. I will do this in your graph. Then, right? This is negative 0.110. Omit, right? You do not include that one. We want this other one. So second trace 5. I'm going to travel to it. Enter, enter, enter. 7.26. 7.26. So I'm going to go over here. 7.260. So that's the actual x-intercept on the parabola, but what does it ask for again? It takes 7.26, is it minutes, seconds, right? It's seconds in this case, to hit the ground. Okay, 7.26 seconds airborne till it hits the ground. D. So write this down. I might be going a little fast, so I put the brakes on. I hope you can see that all right. So, right, if I'm finding the vertex, the x-intercept, the y-intercept, would be nothing new here except for now we're being a bit more specific, right? D, calculate the height of the ball 1.5 seconds after being hit. So it's basically saying when x is equal to 1.5 seconds, they're asking what's y going to be? What function did we use to figure that out? Second trace value, yes. Second trace value, which is 1, right? And then we'll let x equal 1.5. And that will give us the y value. In this case, you can just do that. So second trace 1, x is 1.5. And there it is. It should be blinking right on the line. And it's 45.48. 45.48 feet. Okay, if you answer it like that, I'm happy. So that's how high off the ground it will be after that many seconds. E, too many questions, right? Determine the time the ball remains at or above 49 feet. Now, if you're falling asleep on me, this is where you need to wake up. This one right here. This one is going to be worth 2 marks if it ever shows up. Let's make a sketch right here with me, just a short sketch, right? We know the graphs is not on the ground, starts off the ground, does this, boom, right? And we are asked this. If the height is, like, we kind of have to have a marker, which is our 49 feet marker, right? We know that if y is equal to 49 feet, right, somewhere in here. Okay, follow me very carefully. So there is a time, write this down like this. There is the first time that happens, right? On its way up, gets hit, and then all of a sudden, boom, it hits the 49 feet mark, and then it stays above it, right? It stays above until it reaches a point where it's back to 49. Write that down, arrow down. That's a second x value, right? Like we're dealing with the time 1, time 2. You want to do it that way? Sure. It's the same thing. X values represent time, time represents x. So what are we going to do here? Sorry. So you grab your calculator. You go y equals, you know how we used to do y2 is equal to 0? We are now going to replace that with 49. Oh, is it 49? Yeah, it is 49. So you type in 49 there. You hit graph. And there it is. You see it? So now you know this stretch here is where the parabola stays at or above 49 feet. Right? So how am I going to tackle this one? I'm going to find the first intersection, like the first time it happens. Second trace 5, it's still intersect. Go as close as you can to it. That's close enough. Enter, enter, enter. 4 decimals, guys, 4 decimals. 1.6816, right? 1.6816. 1.6816. It's because we don't want to round too early. Because if you round to 2 decimals here and then round 2 decimals again later, you're going to lose marks. Okay? 1.6816. If you can't see it, just listen to what I'm saying. Okay? Then we're going to find the second instance. Second trace 5. We're going to go over the hill or shortcut, jump lines, go over to the other side. And that's 5.4613. You see that? If you round it to 4 decimals, 4613. 5.4613. Are we good? What are we going to do with this, with these two numbers? We're going to subtract them, right? If we subtract, right, if you take this away from that, then you know the time that went by in between those two instances, right? So that's what we're going to do. Delta time. Have you ever seen delta in physics or science, right? Delta is just the difference. We're going to go time 2 minus time 1. So we're going to go 5.4613 minus 1.6816. So quit to your home screen. No, not on your phone, on the calculator. Caught you in the act, right? There we go. 3.78 seconds. This is right at or above 49 feet. I want to propose something a little crazy here. Could you figure out how long the ball stayed under 49 feet? Yeah. You know how the easiest way right now to do it would be, how long did it take in total until it hits the ground? We answered that earlier, 7.26, right? If you go 7.26 minus the time you were at or above 49 feet, then the rest must be the times you were below it. Does that make sense? Right? We figured out this, right? Right? That told us how long we were at or above. So now Mr. Dirksen kind of makes life even more complicated, right? And wants to figure out, hey, what about it being below? This is just an addition. Below 49 feet, I'm going to go 7.26 minus 3.78. I don't have this on my original, but I'm teaching grade 12 applied right now, and this is a very, very handy concept to know. What are we at? Seconds? I'm going to highlight that pink. You pink, you know it all until there's more. All right. What are we at now? Is it the graphing time? F is the graphing the scenario. So I actually wanted this to be side by side, okay? So open your booklets so that you have all this information readily available right next to it. I won't see it on my camera, right? But I'm just gonna ask you to always just peek. And remember, intercepts, scale, vertex, labels. Maybe I can make like a rap song with that. No, I'm not going to do that. Don't worry about it. You've seen the factoring one, right? There's a bunch of rap songs on factoring. I would make a country song anyways if I had to do it. So here is time. And remember, it has to have the units, times in seconds. And y would be height in, I always have to check because I turn this into yards. Yeah, so this is feet. I could do yards, meters, inches, you name it. Okay. So do that first. Labels are technically done, but let's do the other label right off the bat. Doesn't hurt. Negative 4.9 t squared plus 35t plus 4. Okay. And then you just grab your points and develop a scale system. I look at, maybe I will do that on the side here. You don't need to do this every time, but the x-intercept is this. The y-intercept is this. The vertex is 3.57, 66.5, right? Like if you have these points, and you can't see them right now because I need a camera volunteer here. But those are the 3 points that I'm considering. You're like, Mr. Erickson, what about the other x-intercept? No negatives, remember. So it's almost like just stick with a positive because it's time, right? So if I want to make sure the 7.26 fits on here, let's try this. 1, 2, 3, 4, 5, 6 is not going to work unless you extend it, right? So I'm going to go 2, 4, 6, 8, right? So you should see some some lines here. Every fourth box for me is 2 right now. That's my increment. That's what I chose. You can go up by 1.5, whatever. I just try to go nice and round numbers. And then for the vertex to fit in, I need to go all the way up to, 70 or 80, something like that. So I'm going to try this. 10, 20, 30, 40, 50, it's not going to work. So I'm going to go up by 20. 20, 40, 60, 80, and that's good enough. Right? So I try things before I write them down. You see that I'm doing that, right? Okay, let's plug in our points. So 0, 4, this would be 10 right there. This is 5, so 4 is just under that first. It should be clear that it's not on the origin. That is very important to me, that it's not on the origin. Then the x-intercept, right, this is 7 right here. This would be 7.5, so 726 is somewhere in there. And then the vertex is 3.57, so right about there, all the way to 66, which is there, right? Because this would be the 70 mark, so 66 is right about there. And there you have your points. So I always start, maybe not, but I try to go vertex, out and down, curve it like that, and do the same going the other way. And I have the equation show up on that piece of paper. I have my labels. I have all the points clearly indicated. I have a scale, 3 out of 3, right? 3 out of 3. So we're not done yet. Sometimes either a textbook question or a workbook will ask you to graph right away. I would say hold it. I'm going to answer questions first. I'm not going to do the graph because chances are that everything you need to graph, you're going to have to solve for anyways. Right? So then don't graph right away. I would hold it. If that's all it's asking, find your vertex, find your x-intercept, do all of that for sure, but be smart about it. G, right under the graph. G, what is it asking for? The domain and range of this scenario. We assume that the ball stops upon hitting the ground, right? Like it doesn't continue rolling or anything like that. So for my domain, I'm going from time 0 to time 7.26, correct? And for the range, this is where a lot of students get it wrong. It's like, oh, from 4 all the way to the highest point. But remember, this parabola keeps going and it hits the ground, right? So 0 is part of the story here, all the way to the highest point, which is 66.5 feet. And I'm just going to keep it like that because that's my preferred method. H, watch this. I'm putting a little bit of a curveball. It's baseball after all, right? State the domain and range of this scenario, assuming that the ball was caught. Watch this. It was caught 6 feet above the ground. So that's where the story ends. Let's do a little sketch. It's caught here somewhere, right? Because this is 0, 4. We know that here it's 6 feet, right? We know that it's caught 6 feet above ground. Somebody's catching it. I have my vertex here. Does the vertex change? Nope. 3.57, 66.5. This one is tricky. This would be worth 3 marks. Okay. For my domain, do I know? I know it starts at time 0, but do I know when it ends? Like it gets caught right here. How would I find this? The x value. Y2 is equal to 6 second trace 5. Okay. And so watch this. I'm going to go arrow to the step that I need to take, and then I will go arrow to fill in my domain. So many arrows. Because remember, now the story ends a little sooner, right? It's not 7.26 when it hits the ground. It stops a little sooner. So let's go to y equals, because you basically know your y value. That's what I always do. If you know the y value, put it into your calculator in y2. Hit graph. So we're interested right now in this point right here, out here. So second trace 5. I'm going to travel over. Enter, enter, enter. So that's 7.09. Watch the time. 7.096. 7.096. So I'm going to take that 7.09, and that's now my domain is this. You can do this, guys. You just have to think through it. What about the range? What's the lowest y value ever in this story? 4, cuatro, right? In Spanish. And what's the highest it ever reaches? 66.5. And you're like, what about the 6? It's still it's within this range, right? The 6 is in there. But you're saying, hey, the lowest ever, the highest ever that the y values reach is right here. Yeah, go ahead. Is there something else? One more. This is the grand finale. I will box this in, guys. I will box this whole thing in because there's too much action here. Why would you even do that, Mr. Erickson? Why don't you just leave it? I like to use one example to do multiple strategies. I is for me, it's dear to my heart, okay? Because that really lets me see whether or not you understand things. It says, go read I with me. I'm going to read it out loud, but you read it. Write another equation that would model the path of a ball with a lower maximum height. With a lower maximum height. Let's go to y equals. Let's try things. Let's try things. So I'm going to copy everything except for maybe that last value. So watch what I'm going to do. Negative 4.9 x squared plus 35x. Can I go plus 1 maybe? So it's a shorter, it's maybe like a 5-year-old kid, right? And let's graph that. It's hard to see, but do you see that it's not as high as the previous one, right? You could go -2, right? But that wouldn't be realistic, right? So that would be one way of doing it. So example, decrease y-intercept or the value of c. So we would go h of t, right? H of t is negative 4.9 t squared plus 35t plus, let's say, 2, right? So instead of 4, it's 2. So if you wanted a higher maximum height, Mr. Dirksen comes in, right? I'm going to hit it a lot higher than everybody else, right? Taller. So this would be like a plus 5 or 6 or 7, right? So anyways, what about, let's try another thing. Let's go to the y2, keep the 4 as is, change that to a 4. What else can we play around with? Can we make it a wider parabola? Right, that it's wider. So how would we make it wider? Right, the bigger than 1, it makes it narrow, narrow, narrow. So you want to make it a little bit smaller. So let's go 3.9. Right, the closer to 1 you're going to get, the wider it gets. Hit graph. Oh, what happened? Right, it did the opposite. So I was wrong. Let's change that to a 5. Make it narrower. There we go. It is a narrower parabola. So that did the trick as well, because you can see the maximum height is under, right? Or increase A, right? Example, I'm going to go copy it. Negative 5.9 t squared plus 35t, and we're going to keep everything else the same. So here I changed the c value, here I changed the. So you have the calculator to help you out, right? Just do something with it. I think changing the a value is probably worth trying. Changing the last value is a slam dunk, right? Like that would be the easiest thing to change. Could you change the b value? Probably. So you could try it out. I would, if it works, it works. Okay, guys. What's next? What am I going to do now? Well, I agree you have a long weekend, and I want you to have a little bit of fun, right? But I need you to also start working through these questions. So if you grab your workbook, or if you just write down the pages, I'm going to guide you through these. And these are I made these to help you out, to make you practice. So pages, it says it at the bottom of this page actually. I just want to confirm, because I've been told that those pages do not always add up. So this is actually confirmed that that works out. I will post the keys to that. Let me just see if there's maybe a hiccup, something that may cause you a bit of trouble. I think that you should probably, if I would be given a choice, I would focus more on pages 8 to 9. 6 to 7, right? 8 to 9. This is the one I would, if you can't do them all, I would focus on those. And I will post the key. It's completely worked out. It's not just the answers, it's like the whole thing. Okay. So I will post that shortly after.